How are you doing? This video is demonstrating the Gazebo capabilities of the project found at GitHub, Toronto Robotics Club, Jimmy repository. If you come to this repository, you will see that there's a README file. This README file right here. And this README file is quite useful. It covers the software. It explains some of the dependencies, which include the libserial POSIX library. It explains that in order to run the Gazebo simulation, you need an NVIDIA card. It speaks about the other packages that have to be installed in order to run navigation, how to build the code, which is what I'm doing in this window right now. It explains how to run the code. And we run the code using these launch files here, which make everything very convenient for you. Speaking of launch files, what we're going to do now is we're going to launch one by one these files right here. So let's do so. Okay. So we're starting the first launch file. Okay, first we get RViz with the LiDAR homing. Scooch it over here. This is our teleop terminal, and of course Gazebo. Okay, so in order to teleop the robot, simply click on the terminal and W to go forward, A and D to turn, as is shown on the terminal, and the robot moves. Very exciting. Okay, let me demonstrate the next launch file, which is B Gazebo navigation map building. So this launch file shows exactly what we just saw, with the addition of G mapping in order to generate a static map. Okay. And of course, Gazebo just crashed. Okay, so we're going to relaunch. Okay, here we go. And the concept here is that as you teleop the robot, let's just get it to spin, the map will get constructed. Okay? We can see the G mapping messages rolling in here, and you would continue to teleop until you've built the map. Very exciting. So what we're going to do next is we're going to run the Gazebo navigation on map launch, which is demonstrating where the robot currently is with the navigation stack. Okay, there we go with Arviz. Everything's very happy. Now you will notice that when Arviz loads, it loads a configuration for each launch file where it gives you the appropriate layers to make everything very convenient. Okay, so now what we're going to do is we're going to give a navigation goal. Let's get it over here because that'll be fun, and we can watch the navigation stack at work. So for the next move, I'm going to remove the robot model, the transforms. I'm going to remove the local cost map. I'm going to remove the particle cloud so we can see the global path, the local path, and you can see that we did stop in the correct orientation with a little bit of spinning, which was annoying, but Bob's your uncle. Okay, so now we're gonna send it over here, and we can see the global path planning is decent, and the local path planning is also not bad. There we go. Motion achieved. Now, quick note on the Gazebo files. I don't really care so much about the Gazebo files, largely because I have a physical robot. So you will see that the front wheels have a slow rotation about them, and so do the rear wheels, but there's zero friction on these wheels, so there's no effect on the robot from these wheels. Another thing we can see is that it's not really bouncing around, so this is good enough for a demo. The next video is going to demonstrate the physical robot.